Okay, so fundamental theorem of calculus, we've got part 1 and part 2. It's not important that you can distinguish between the two parts, but it's important that you can use both parts. One of the parts you used like crazy last year and you remember it. The other part is a lot of times on a free response question, and hopefully you're good at it, but a lot of times first year calculus students struggle recognizing it, knowing what to do with it. So here it says, if f is continuous on a to b, then the function g, defined by this, is continuous on a to b and differentiable. So what this is saying here is if I start with this, and if I take the derivative of this side, I'm going to end up with getting rid of the integral here, because when I take the derivative, isn't that the same as taking the antiderivative and the derivative? This would just cancel out, so we'd just be left with f of x. So if you're given something like this, you should be able to write this statement here. So here it says, let g of x actually equal this. So we would write that as g prime of x is equal to f of x. And the thing that you have to be careful of here is that the x is on the top. If the x is not on the top, you can't do that direct substitution. Okay, if it's like a 2x up there, you will have to apply the chain rule, those type of things, but we'll see that later on here. Okay, so we're trying to evaluate g of x for 0, 1, 2, 3, 4, 5, and 6. So let's do 0 and 1 and maybe 2 here together. Okay, so if we plug in 0 here, we're plugging 0 in for x. So we're plugging 0 in here for x. So it would be the integral from 0 to 0 of who cares, because what's that going to equal? 0, right? Because we're talking, when we're talking integral, we're talking how much area is covered from here to here. So there's no area. That's all right. So g of 0 is 0. Down here, we're trying to sketch a rough graph of g. So we know g of 0 is 0. We could plot that point down here. Kind of start that problem as well. Okay, now if I'm trying to find g of 1, we're talking about the integral from 0 to 1 of our function. So this is our f of t. It says where f is a function whose graph is shown. So if I'm going from 0 to 1, we're talking about the area that's covered from 0 to 1. So how much area is covered there? A half. So then on your graph at 1, you have a half. So this is the graph of g down here. Okay, so go ahead and find g of 2, 3, 4, 5, and 6. Then I'll write them up here, and you can compare. So see if you're getting the same thing I'm getting here. I'm just doing these as I go. So part D we can really do with what we did in part A up here. We've got our values at those different spots, and then we could sketch our graph in there. I'm not very good at sketching on this thing sometimes, but it's a rough graph or a rough sketch, so that's okay. So a rough sketch of that would look something like this, right? Okay, so estimate g of 7. Why does it say estimate? Because it's kind of curved, okay? So we're kind of counting the boxes really there. So g of 6, so to find g of 7, sometimes you'll see things written like this. You'll go and you'll take what g of 6 is, and then we have to add on the integral from where? 6 to 7, right? So a lot of times you see it written like that on the AP test or like within their answer key, so it's good to understand what that's saying. So g of 6 was 4, and then we're finding the area from 6 to 7, which is approximately what? 2? Yeah, it might be a little less than 2, so I would say 2 would be a high estimate. Yeah, 1.5 is definitely low, right? So it'll be somewhere between 1.5 and 2. So we could put here approximately instead of equal to. Okay, and then where does G have a maximum value? Where does it have a minimum value? That's where sometimes it's nice to do the sketch first. Where does it have a maximum value? So it has a maximum value when x equals 1. And where does it have a minimum value?
X equals 4. No. Did I do that wrong? 3.
Yeah. Okay, and then sketch a rough graph. We've got that part done. So questions on that? Remember, when you're talking integral, you're really looking at the area. And a lot of times these will show up on those free response questions, and you have to work your way through it. So when you see something that looks like this on the AP test, that's one of these where you're going to be breaking it down. Sometimes you just plug into the integral, and then sometimes we'll do more like this stuff. Okay, let's go to the next page here. Yep. Okay, so back here where it says where does it have a max or where does it have a min, this is talking, it should really say a relative or a local max or a relative or local min. Because if you look at this graph, does it have an absolute max? I mean, it possibly could, right? But we're not sure. And this is all we're given of this graph. So let's just switch that so it says relative. That's a good point there. Is everyone okay with that? Because really then, isn't it going to have another max at this spot here? Because it's got that positive area that's coming to an end, so there'd be another max at this spot here. So whenever a positive area comes to an end, there'd be a local or relative max at that spot. Whenever a negative area or a negative chunk of the graph there, it's below the x-axis, whenever that comes to an end, that's where it's going to have those local or relative mins. Okay? So here, use part 1 of the fundamental theorem to find the derivative of the given functions. And here's where people just crazy overthink stuff because they are not, maybe it doesn't say use the fundamental theorem of calculus there. When we're trying to do this, if we're trying to find the derivative, first make sure that the variable is on top. And then if we're finding the derivative, which is important because some people forget that that's what we're doing. So if we're finding the derivative, all you have to do is plug that in for all of the variables in here, and you get rid of your dt then. So this would say y squared sine of y. And that's your derivative. So for this one here, what would I have to do in a first step in order to use this? Switch it. So you put a negative out front. Good. So we're going from 2 to x. It does not matter what this value is. Okay, it could be any number. So now I've got cosine of t squared dt, and then you can just do your substitution. Remember, we're finding the derivative. So the negative stays out front, x gets plugged in, so it'd be cosine of x squared. Does that look okay to everyone? And it says find the derivative, so we're done. We don't actually have to take the derivative of that, okay? Now here's where some people kind of forget sometimes, but first thing we want to do is get the x on the top, so we're going to go ahead and flip it, put a negative out front. Is that a minus 3x, right? Okay, then you're going to substitute this in for all of the u's there, so let's do that. And then chain rule has to go on the back. So your chain rule is multiplied by the derivative of that inside function, which is what? -3. So then you can actually change both those negatives to turn into a +3 on the top. And then you've got the 1 minus 3x cubed. And then the denominator, I would just leave it like this unless you're forced to switch it. Because you can't like cancel that. This is 1 plus this, so you can't factor it out or anything there. Does that look okay to everyone? So if this is not just like an x up there, then you have to make sure that you apply the chain rule by multiplying by it. The book explains it in a much more difficult way that I used to try to do. This is way easier. Just think of it as the chain rule, okay? It doesn't matter what it is. Yep, so if it was, let's say, x squared, then you'd multiply by 2x back here, okay? Yep. Okay, any other questions? Okay. So let's go to part 2. Part 2 is what you're going to be more comfortable with here. So using part 2, all you're going to do is take your antiderivative of what's in here, and then you plug in the top, and you subtract, and you plug in the bottom. I want to say there was a typo, but maybe I fixed it. I think we're okay here. So use part 2 to evaluate or to explain why it doesn't exist. So first thing we're going to do is take the antiderivative of x to the 5th, which is 1/6x to the 6th. And then we're going from -1 to 3, so that's how you would write that. And then you're going to plug in 3. And then you're going to subtract, and you're going to plug in -1. Okay, so 3 to the 6th, we're doing 3 times 3, which is 9, times 3 times 3, which is 9, times 3 times 3, which is 9. So 9 times 9 is 81, times 9 would give you, does that seem right? Okay, so you should be able to do some mental math there. Sometimes people aren't very quick at it, but try to find ways to be quicker. And then back here, this turns into what? Still minus, right? So we get 728 over 6, which could reduce down if you want to. You could take 2 out of the top, 2 out of the bottom. Okay, so go ahead and try the rest of this page here. I'm going to give you 3 minutes to get a head start there. Okay, I'll start working through the second one so you can check. If you're done with the second one, you got 7/8, so you can move on here. But this, you're just starting with this as the integral from 1 to 2 of 3t to the -4th. The 3 you can pull out front and kind of, pretend it's not there while you do the antiderivative. So you add 1 to your exponent, which turns into t to the -3rd. And then you do what? Divide by -3. So you're dividing by -3 there. And you're going to evaluate it from 1 to 2, but I'm going to clean it up here and just write this as negative, and I'm even going to do 1 over t cubed. And then we're going from 1 to 2. So plug in the 2. So we got -1 over 2 cubed. I'm just going to keep it simple to start. And then you subtract. Oh, that was your 3 minutes. Then we're subtracting, and you plug in your 1. So -1 over 1 cubed. Okay, so this turns into -1/8 plus 1, which is 8/8. So you get 7/8. Just at the end of it, yep. Okay, any ideas on the next one there?
0.
0, thank you. Why? 3 to 3, right? So sometimes we start and we get crazy into a problem and have no idea how to do it, and we try to use substitutions or weird things. Okay, sometimes they're more basic than that. Okay, this one here, to take the antiderivative of sine, it's going to be negative cosine. And we're going from pi over 4 to pi over 3. So we're going to plug in pi over 3 first, and then we're subtracting, and we're plugging in pi over 4. So here's where you have to know your unit circle. What is cosine of pi over 3? A half. So this turns into negative a half because the negative out front. And then two negatives make a positive. And what is cosine of pi over 4? Square root of 2 over 2. So they already have that common denominator. And typically they put the positive term first, so you'd probably see it like that. Questions on that at all? Okay, so over here we should be okay with these. We should be okay with these integrals, but sometimes we're not. This here, what kind of a function is in the denominator? Linear, so what are we going to use? Natural log. Now there's two ways you can do this problem, okay? Because it's a linear function with only the slope and the x and not a plus b, you could just take a half out front of your integral, and then you would just have your natural log of the absolute value of x with your half out front. Or you can leave the 2x in there, and this is how I would probably rather have you practice it, because this will be more valuable for all types of linear functions down here, is you do natural log of the absolute value of what's in here, right? And then what do I have to put out front if I do that? The half out front. 1 over your slope has to go out front.
Why? Oh.
Yeah, it's kind of like a u substitution is really what it is. But when it's linear, there's such quick u substitutions, and we use them all the time, that doing a u substitution every single time wastes a lot of time. But your u here would be 2x, and the derivative of your u would be 2 dx. So if you had your integral, this would be 1 over u, and then your dx would turn into du over 2. So that half would be out front. That's where that half comes from. And then the integral of 1 over u is natural log the absolute value of u, but our u is 2x. Do you see where that comes from?
But how is it the same if you got 1/2 dollar half?
Yeah, no, I understand, because I was just thinking the same thing. When you pull the half out front, we'll see. Let's do it both ways and see what happens here, because I'm curious as well. Okay, so this here is doing our u substitution. Do we have another question? Okay, so here's doing our u substitution, and then we're going from 1 to 9. So we're going to plug in the 9 first, which gives us the natural log of 18 minus a half natural log of 2. And now this is not how it would be written on multiple choice. With natural logs, they're going to try to combine as much stuff together as they can. So I'm going to take a half out front. And so I've got natural log of 18 minus natural log of 2. How can I put those together? Divide. So 18 divided by 2 would give me 9. And then what can I do with that half that's out front? Take it to, yeah, you make it an exponent. So 9 to the half power is, so natural log of 3, right? Because it's natural log of 9 to the half, or square root of 9, which is 3. Okay, so if we do this with, yeah, pulling the half out front, do we get the same thing at the end? Okay. So whoever had that question with, okay, if I pull the half out front and I've got the integral of 1 over x and I do it that way, so I've got 1/2 natural log absolute value of x, it's just going to turn into the 9 and the 1 here. So it kind of skips, which will give you the same thing at the end. So both of them work. It doesn't matter which way you decide to go with it. Even though they don't look the same, they end up the same. Where this, which half? This half out front?
First one. Yeah.
Okay, so this half is from U substitution. So let's do it with a U substitution. Whenever you have a linear function, you need to do 1 over the slope out front. And that's the shortcut, but the long way to do it is using your U substitution. So our U is 2x. The derivative is 2dx. And then you solve for dx, which is half of du. So then we've got the 1 over u and the 1/2 du. Are you seeing where it's coming from?
Okay, yeah, I do.
Okay. So other questions? Okay, we'll use a lot of those shortcut things to make the problems go quicker, because BC problems tend to take longer than AB problems do. And trying to do a U substitution within a more complex BC problem really eats up time and overcomplicates the problem. Who recognizes this one here? It's the potato problem? Yeah. The 6 can go out front if that makes it easier. Inverse tangent. So we got 6 and then inverse tangent of x. I think they're talking about the potato problem. Yeah. Okay, so we plug in the top, and then we subtract, and we plug in the bottom. Now this one back here is easy. What is the inverse tangent of 1? Where is tangent equal to 1? Yeah, sine and cosine would have to be the same for tangent to be 1, right? Because sine over cosine to be 1, those have to be equivalent. So this would be at pi over 4. Now this one's a little bit harder. Where is tangent square root of 3? So it's either going to be square root of 3 over 2 divided by 1/2, or 1/2 divided by square root of 3 over 2. Which one of these gives me square root of 3? The first one, right? Multiply by 2 over 1 and you get square root of 3. So we're looking at this one here. Yeah. So we're talking about when the sine is square root of 3 over 2 and cosine is 1/2, which happens at pi over 3. So this says 6 times pi over 3, which gives me 2 pi, minus 6 times pi over 4, 3/2 pi. I'll probably write that. It might be easier than to do your mental math for the next part. So 2 pi minus 1.5 pi. You're left with 1/2 a pi. Okay, so questions on that? There's not a lot of, having to do inverse stuff like that on the AP test, but it happens on occasion. It's good to have that ready to go if you don't have your calculator. Oh. Okay. No. Okay, so we're taking a look at this one here. The problem with this one is we're going from 0 to 2, and this goes from, it's a piecewise function that splits at 1. So what you would have to do here is you'd have to go from 0 to 1, and which function would be inside there for that one? X to the 4th. And then you'd have to add that to the one that goes from 1 to 2, and inside there we've got x to the 5th. Okay, so everybody do that, and we'll check if we get the right answer at the end. So I'm getting a fifth and 63.6 to add together there. I'm not sure if that's what everyone else is getting. The 63.6 you could reduce down. It might make it easier to get a common denominator, but you wouldn't have to. I'm getting 107 tenths, or 10.7 obviously that would be. So double check that, and then you guys can work on homework there.